Welcome to the Bodhi Academy. My name is Amisha Kulaso, and in today's video, we will do the chapter Symmetry, Class 7, Chapter 12. To begin with, let's understand what does symmetry mean. So, symmetry is an important geometrical concept commonly exhibited in nature and is used almost in every field of activity. So, it is a geometrical concept and it is used in most of the fields in everyday basis. Artists, professionals, designers of clothing or jewelry, car manufacturers, architects, and many others make use of the idea of symmetry. The beehives, the flowers, the tree leaves, religious symbols, rugs, and handkerchiefs, everywhere you find symmetrical design. Now, what does basically symmetrical design mean? Now, say I have a square over here. Okay, I have a square here. Now, I say that this square is symmetric. Now, when I say the square is symmetric, what does it basically mean? It simply means that if I fold or if I divide the square into two halves, okay? If I fold or if I divide this box or the square into two halves, I will get two equal parts as in the mirror image. If I fold this and this side will be same. It will be exactly the same. This means that it has symmetry. Now say I draw any random shape, okay? Now if I fold this in any direction, say vertically, horizontally, or even diagonally, I won't get the same half on the other side. This half and this half is completely different. So therefore this does not have symmetry. So this is the basic idea of symmetry. Now look at this building here. So this is an architectural building. See, on passing a line from here, you get the exact replica of the one side on the other side. Similarly, for this car you see. Now these are now architects, these are car engineers, this is the nature. Everywhere you see this kind of symmetry that is present. Now you have already had a feel of line of symmetry in your previous class. So what is line of symmetry? This line that is drawn here which divides the object into two equal parts is known as the line of symmetry. A figure has a line of symmetry if there is a line about which the figure may be folded so that the two parts of the figure will coincide. Now, if I fold this image or this picture, if I fold, they will coincide perfectly. This part will come on this part will come on this side. So, they are perfectly coinciding with each other. You might like to recall these ideas. Here are some activities to help you. So here they have done different designs which are basically exact replica of each other on both the sides. Enjoy identifying lines also called axes of symmetry in the designs you collect. So they are also called as axis of symmetry. Line of symmetry is also called as axis of symmetry. Now let us now strengthen our ideas on symmetry further. Study the following figures in which the lines of symmetry are marked with dotted lines. Now see here. This is the alphabet T. Okay. So if you fold this in this direction where the line of symmetry is marked, this is the line of symmetry. Okay. So this is the line of symmetry. And if we fold it in these two halves, we will get exactly the opposite of the equal side of other. They will coincide with this side. So just like there is this outer section on this side, there is also on the other side. So they are going to coincide with each other. Similarly, in these examples, we'll see similar line of symmetry that divides the object equally in two parts. Now, Lines of symmetry for regular polygons. You know that a polygon is a closed figure made up of several line segments. The polygon made up of the least number of line segments is the triangle. So any polygon is basically any shape that is made up of several line segments. Now out of all of them, triangle is the one which is made up of least line segments because it has only 1, 2 and 3 line segments that make up the triangle. Now, a polygon is said to be regular if all its sides are equal length and all its angles are of equal measures. So, now what is a regular polygon? So, they are saying that these angles which are there, triangle has 3 angles and these 3 sides which are there, they have to be equal. Only then we call it a regular polygon. Thus, an equilateral triangle is a regular polygon of 3 sides. Can you name a regular polygon of 4 sides? Obviously, it will be which one? 4 sides. So, we'll have 1, 2, 3 and 4. So, that becomes the square. Now, equilateral triangle is a regular because each of its sides has the same length. So, see, these will be equal in length, all these sides. So, they have denoted it by A because A is going to be same throughout. And each of its angle measures 60 degrees. So, each angle is going to measure 60 degrees. Therefore, it is an equilateral triangle. A square is also regular because all its sides of equal length and each of its angles is a right angle. So what we understand by right angle is that any angle that makes up a 90 degree. So 90 degree we understand that it is right angle. Here it wasn't 90 degree, it was 60 degree. So you see there is a slight bend. If this is like this, if this is straight like this, okay, then it becomes a 90 degree angle. So triangle has a 60 degree angle and a square has a 90 degree angle. Its diagonals are seen to be perpendicular bisectors of one another. Meaning, see, here it is going in this direction. This is one diagonal. This is the other diagonal. So they are perpendicular to each other. See, perpendicular as in it should form this. Okay, a ulta T. So see here now, this diagonal is forming here with this one. Then this one forms with this one. So similarly on all sides they are forming perpendicular bisectors of each other. Now, if a pentagon is regular, naturally its all sides should have equal length. Pentagon meaning it has 5 sides. So, see 1, 2, 3, 4 and 5. And this one will be what? How many sides? 1, 2, 3, 4, 5 and 6. So, this is a hexagon. Okay, if a pentagon is regularly, naturally its all sides should have equal length. You will later on learn that measure of each of its angle is 108. So here all of these angles which are there are 108 degree. So this is also 108. Why 108? Because it is equilateral, right? All of its angles and sides are going to be equal. Now see, this can form a triangle within itself. So if we draw like this, so we can say what? There are 1, 2, 3, 4 and 5. So we say that 5 triangles make one pentagon. Now these triangles are not equilateral triangles, okay? They have two different sides. So they will be called isosceles triangles. So 5 isosceles triangles will make one pentagon. So see here, this 54 plus this 54. This angle will also be 54. This angle will be 54. This is 54. 54, 54 together forms this 108 degree. Sorry. So, a regular hexagon has all its sides equal and each of its angle measure 120. Now see here, each of its angles are measuring 120 in hexagon. In pentagon, it was 108. You will learn more of these figures later. A regular polygons are symmetrical figures and hence their lines of symmetry are quite interesting. Each regular polygon has many lines of symmetries as it has sides. We say they have multiple lines of symmetry. Now, it is like this. See, now for a triangle, first initially we saw only one line of symmetry, that is this. Okay, a straight line of symmetry that passes. But now see, is there any other way we can divide it? Yes. See, there is another one here in this case and then here. So we say that a equilateral triangle has three lines of symmetries. So 1, 2 and 3. No matter you fold it in any of these lines, it will give you equal sides. Now see here, there is a square. Now for square, we can have even more. So we have here 1, 2, 3 and 4. So basically know what we can prove here is that say lines of symmetry, they are equal to number of sides. Okay. So now what does this mean is that now see triangle. Triangle has how many sides? It has 3. So automatically lines of symmetry will also be 3. So we are having 3 lines of symmetry. Square has 4 sides. So therefore it will have 4 lines of symmetry. Pentagon has 5 sides. It will have 5 lines of symmetry. And regular hexagon has 6 sides. So therefore it will have 6 lines of symmetry. So for any regular polygon, the number of lines of symmetry is always equal to the number of sides they. Perhaps you might like to investigate this by folding paper. Go ahead. The concept of line symmetry is closely related to mirror reflection. A shape has symmetry when one of it is the mirror image of other. So what they are saying is that now when do we say it has any object is said to have symmetry? Okay, when they are mirror images of each other. Okay, they are said to have symmetry when they are mirror images of each other. If they don't have mirror images, then they are said they do not have symmetry. Now look at this triangle. Is it a regular triangle? No, it is not a regular triangle. Why? This length A and A are equal, but this length here is quite smaller as compared to A and A. So this is not a regular triangle or it is not an equilateral triangle. So now if you try to take mirror image of this from the below, like you place the mirror at this point, you place the mirror here, okay, horizontally. What you will see? You will see a triangle, but it won't be same. So is the dotted line a mirror line? No. But now see, here you have this triangle, okay, and you place the mirror vertical right at this point, this line of symmetry. Now what you will see? You will see exactly the mirror image of this. So is the dotted line a mirror line? Yes, in that case. Now while dealing with mirror reflections, care is needed to note down that the left right changes in orientation as seen in the figure here. So one thing we know about mirrors is that your left, okay, your normal left and your mirror. Your normal left in the mirror is your right and your normal right in the mirror is your left. Okay. So this we need to remember. Now see, there is this alphabet and I place a mirror here. What I will get? I will get a mirror image. That is, the right will become left and the left will become right in this case. The shape is same, but it is the other way round. Now, play this punching game. In this, what they have done simply is that they have taken a sheet of paper, okay? Then they have punched a hole at this point. So now, what will happen? The hole will come on two different places. And it will be in symmetry. It will be exactly at the same point as the other one. So, a fold is a line or axis of symmetry. Study about punches at different locations on the folded paper and the corresponding lines of symmetry. Now see. Copy the figures with punched holes and find the axis of symmetry for the following. Now you have to draw the axis of symmetry in each of these cases. So first one, where will be the axis of symmetry? So the points are here and here at the extreme ends. So therefore it means that the paper was folded like this from the center, right? So it was folded from the center. So the paper would be basically like this, right? The hole might be punched over here. So when you open, you will get this, correct? Now see, in this case, they are at the two corners. So here, line of symmetry will be diagonal, okay? So we'll get a triangle in this case and the holes will be punched here. In this case, again, the holes will be, as in the line of symmetry will be here, in between the square. So then you will get this and hole is here for this one. Now here also see again what might have happened here. Here they have made two holes. So when you divide the paper like this, you will get, okay, will get this. Okay, we'll get this. Now in this case, what they have done? They have punched one hole over here and one hole over here. So when you open up, you will get this. Okay, understood? So similarly, we can do rest of the example. Now in this C, here they have given us the line of symmetry. We have to tell where basically the hole will be coming. So in this case, first the hole will be coming over here, this point. Okay. Here it is at the end. So above also it will come at this end. Here then obviously here in this case we'll get it here and here. Okay. So like this we have to solve this examples. So here now, see there are some examples over here. So state the number of lines of symmetry for the following figures. So equilateral triangle we know it is already 3. Square we know already how much it will have, 4 sides. 4 lines of symmetry because it has 4 sides. So similarly we have to do the rest of these example. Now see here, what letters of English alphabet have reflection symmetry? That is symmetry related to mirror reflection. Now when we say vertical mirror, now say consider the alphabet A. Okay. Now say vertical mirror means what? You are going to place the mirror like this. You are going to place the mirror straight. Okay, straight. And horizontal means somewhat like this you will place the mirror. Vertical we know like this, no, standing, and horizontal is this. So we have to place the mirror accordingly. So vertically when you place the mirror for alphabet A, you will get the mirror image exact. Now same thing if you do for B. Vertically you place the mirror. Will you get this on the other side? No. So here you cannot use vertical mirror. Okay. But now say I take again B and I place the mirror horizontally here, right where between the two cuts of B. In that case, I will get both symmetry. So in this case, what I will use is a horizontal mirror. So similarly, you have to write which alphabet, which mirror you are going to use. Now, for both horizontal and vertical mirror. So in this case, which example we can take is alphabet O. In this case, if you place it like this, or if you place it like this, you are going to still get both the same images. Okay, so that was it for today's video. Please don't forget to like, share and subscribe to the Bodhi Academy. Thank you.